Cool. Oh yeah, it's really full. You do know there's another talk in the red room.
Oh, sorry.
Whoa, loud. Okay, anyway, thank you all for being here. I notice I have domain in the title, so I think that might be the reason you're here. Maybe it is because you saw the legacy code. You won't explicitly see legacy code, but you will see parts of legacy code. Anyway, I'm Richard. I enjoy software archaeology. I enjoy testes else, and I enjoy hypermedia. And today I'm going to talk about domain rediscovery, patterns for legacy code. And how did these patterns come about? Because we have the modernization audit we do in our company. And in the modernization audit, because it's like 3 weeks, we usually have more like passive patterns or analyzed patterns. I like the passive part because when we do a project, which takes way longer than 3 weeks, you have the opposite to that. You have the active patterns where you actually do stuff. And together they sort of click together. And with the passive patterns, you see where do I start? Because if you have, I don't know, 200,000, 1 million lines or 5 million lines of code, it's kind of nice to know which of these should I change? And then the active patterns are sort of what to try. Specifically not what to do, but what to try. Because in the end, it's still a software engineer's job to figure out, okay, this thing here, how can I make it better? And you will also see most patterns on the passive side, and I'll sort of quickly jump over the active patterns. And you will explicitly also see very dirty patterns. Because this is the situation you will find in legacy code. It's one index file, not even spelled correctly. But I'm not joking, right? That's a screenshot from a real project. And they didn't have SVN, CVS, whatever, right? The source control was the production server. So when they wanted to make changes, they used remote desktop. They logged into the production server. And because it was VB script, they changed the file. And that was the deployment. So yeah, dirty patterns. The categories are sort of these mind the repository, if you have a repository, and capture the intent, which is something like a test. Could be a fitness function, but I'm not going to be talking about that one. Mind the expert, meaning mind the domain expert. We are at the DDD conference. There's lots of things you can try, lots of things you've heard. Today we won't be talking about it. And there's a fourth category, which are the dirty but useful patterns. And why are they important? Because our highest priority is to satisfy the customer by not changing what doesn't need changing. So we need quite dirty patterns to figure out what doesn't need changing. One of them is activity logging. It's literally log statements. Put them at the right place, which is like the entry point, controllers, whatever. Put them down there where data is written. And based on how often something is written, how often something is logged, you get an understanding of what is potentially critical, because it's used very often. You get an understanding of what is potentially obsolete, because it's not logged at all. The big caveat is, there we go. Some things are cyclical, specifically reports. So, 364 days you haven't seen a log statement, but this one day is the report your CFO makes. So again, it's human judgment in there. But it guides you. And the other one is the legacy toggle. And this is you're going to be saying this is very, very dirty, and you're right. But it's good to know what is obsolete, because then you won't change it, maybe you even will delete it. What's the approach? Well, there's different ones. One of them is add a UI toggle, right? Someone has to press the switch before he can use whatever feature. A bit more dirty is you deactivate it in the backend, and your client just gets an exception. Because you used an environment variable, you can sort of you change it and you reboot the server and then it's there again. But it's still kind of a hard thing, but it goes worse. You can do this. Right? Can we do worse? Yes, we can. You would be surprised how useful that is. It's still human judgment, so I'm not taking away the responsibility, but it's there, it's a thing you can do. Caveat, of course, as usual, right? Some things, reports, and people still might not complain. And that's the thing about legacy code, right? Sometimes users have given up. Sometimes marketing departments have given up. They don't even suggest features anymore, right? So yeah, use with care. But they can really, really help you. Now for the less dirty things. Mining the repository. And the important part is we are mining the repository. So this is an engineering design. You sort of go from abstract down to concrete. That's not what we're doing. We're going backwards. We're starting with the physical system, and we mine it. We try to figure out what does it do. And we go up, and we figure out, okay, what is the concrete description, and so on. And then we go to the abstract model. And I'd like to call this IT archaeology. But it's different, right? It's the other way around. You're not figuring out how do I model this? You're going the other way around. You're saying, how is it modeled? Or is it modeled? Or can I make it more clear? Another warning, we'll be talking about metrics. Probably heard of the first law, right? Every measure which becomes a target becomes a bad measure, because people try to optimize for it, and then it sort of becomes useless. The metric hotspots are only the start of the conversation, and the truth is in the conversation. So if you find something that is, by metric standards bad, there's a reason for that, but you now know where to start the conversation. And of course, we'll be talking about names, and naming is hard. You know the programmer joke? Yeah. Only two hard things in computer science: cache invalidation, naming things. And also, we only have one joke, and it's not funny. But yeah, right, that's the truth. That's our day job, naming stuff. Metrics just tell us where to start. They help us find what domain concept to name. And in the end, it's a process. Right? So this is from DDD Roots, Alo Belshi. And he says naming as a process. Meaning, don't feel bad if you don't find a name. Just name it applesauce. And then later on, figure out what is the domain term behind it. And it's not like applesauce, oh, I perfectly know the domain term. It's like multiple steps in between. And if you're ever interested in, where do I look this up? Well, I usually put stuff down here in the corner. Links. And sometimes you will see like numbers, 1, 2, 3, and then you know, okay, down there in the corner is something important. Going back one slide, and if you want the slides, they're already online, but you will see them in Slack channel. So, first real pattern, the code tag cloud. The idea is to get a high-level overview of possible domain names. And you just extract all the names you can find in code, and you put it in a tag cloud. Caveat, repetition wins. If your CFO has this one function he only calls once a year, it's probably only going to be mentioned in your code once a year. But it's still good to know. And when we apply this to the Spring Pet Clinic, you see this. You see, oh, cool, the Spring Pet Clinic is about pets and owners and visiting and string, right? So is it stringly or strongly typed? And you can clearly see, okay, we can improve this. So of course there's more DDD examples, and one of them is this library project on GitHub, where they went the complete way and they sort of did all the DDD things on this library domain. And this looks much, much stronger, much richer. And if you look for string, it's, where is it? Anyone see it? There. Right? It's hidden inside there somewhere. But if your tag cloud doesn't look like this, and you really put your best effort in it, it could also be that it's because of your service offering. If you have something like the pet clinic or whatever, it's a very specific thing. It has a very specific topic. While the library, the software you're going to use later, is called Codecarte, which is one of our open source projects, and that looks like this. And that's just the way it is, because in the end, in the end we have nodes that we display and we store a lot of metrics. And I put Jenkins and all the other Kafka tools through the tool, and they look very much like this. It's like very generic names because the domain is supposed to be customizable, so in the end it becomes generic in the tag cloud as well. Nevertheless, you look at this and you're like, oh, this could be much richer. Here's some active patterns to get towards strong code tag clouds. In the end, we bring the domain forward. We can model our IDs, which is a very, very simple thing. You just use a record or whatever. You can do this in TypeScript, by the way. It's called branding, if you want to use it. And then the user ID becomes the thing, and you can actually remove bugs that way, because you never can pass, like, I don't know, an author ID where user ID is supposed to be passed, because it's a different type, and your compiler will be like, hey, this is wrong. You can wrap primitive value objects. When you have a string or a number, and string and number have the problem that they are very, very generic. I mean, string is anything. It can be empty, it can be null, it can be whatever. Or number, it can be negative, it can be positive. But if you have a domain constraint, it's like only positive numbers are allowed, only numbers above 1, only, I don't know. Or if it's an age, or a year of birth or something, right? Something below 1900, very unlikely. So you can wrap that. You can see, hey, cool, multiple elements are always passed together. How about extract a parameter object? And then I need to suddenly, and object calisthenics, which was a talk, was it yesterday or the day before? Anyway, if you want that talk, there's 9 object calisthenics you can use to sort of figure a way around and see if you can find more domain terms to name. Now, further patterns. For that, I'm going to be plugging something very shamelessly. I think it's okay because it's open source. You can fork it if you want to. But we are going to be visualizing metrics with Codecarte buildings. So imagine you have a file, some service, and you visualize it as a building. That means you have sort of this area. And you can give this area, if you look from the top, you can give a metric. You can say, okay, the more lines of code I have, the bigger it's going to be. You can give the height a metric, and for example, cyclomatic complexity. And then the more complex, the higher it becomes. And you can give the color to something. You can say, oh, make it red if it only has 1 author. Or the other way around, make it red if it has 20 authors. And with that, we get to a new pattern, which we call cluster invest. And that helps you see where most code was invested. It doesn't mean it's the most important one, but if your most important business functionality doesn't even show up in your map, that kind of also gives you a thought, right? Because then it doesn't have any lines of code. It's like, why isn't it bigger? Why is all my generic stuff so big, but my really important domain stuff so small? Unfortunately, I cannot do this for a real customer project. And if I do this for small toy examples, the map is going to be looking very sad. So I did this for CodeKata, where it looks like this. And you can see CodeKata is kind of about, well, search panel and storing stuff and everything like this. And now you just have to sort of do the transfer yourself and like, okay, how would my map look like? How would the map of my code look like? But if you map lines of code, you can see, well, this code map is very important, and for some reason, one singular file called datamux is as big as like other folders. But yeah, you can sort of look and see, does that match your expectations? Sorry, you're not talking, that's why my throat is getting very raspy. The interesting part is, of course, you now have a passive pattern, and you're like, hey, does that match my expectation? Well, you can turn it around. You can go to the active side. You can sort of see like, okay, maybe I can put my components into focus. And instead of packaging by layer, which might be one reason why you don't really see domain terms in there, instead of saying controller and controller is always in the same folder, you can go the other way around and do a package by component. And say something like, oh, okay, this serves in this repository, I put them in the same folder. And now I expect to see, and I give it the domain name. And now I would expect to see like bigger clusters of real domain functionality. Next pattern. Oh, it's supposed to be passive pattern, I'm sorry. Complexity invest. Now, complexity is a thing that gets thrown around in different contexts and always means something different. In this case, it means cyclomatic complexity, which means how many branches do I have in my code. An else statement is a branch. An if statement is a branch. If I have a switch case, every case statement is a branch, or a potential one. If I have a catch block, it's a branch in the code. It's not linear anymore. I can count that, and if I have lots of one place where lots of these if, else, whatever statements are, that might be a location for lots of domain logic. Because in domain logic, you usually have to decide, do I do that or do I do that? And you can mark that in your map. And one quick caveat. Cyclomatic complexity is a bit controversial because it sort of penalizes switch cases. And there are other different metrics, like cognitive complexity, which Sono calculates, or the bumpy road metric, which is how much indentation do I have, right? If I go like this, my road, right? Every if statement, an if statement, if statement, sort of goes bumpy that way. And it's much easier to read if it's linear, if you have like one if statement and then you go back to the road. There are other ways to do this. Complexity is something that most programs can calculate, and it's a good place to start. For CodeKata, it would like this. And now we put on the height and on the color, we put the cyclomatic complexity. And now we can see, oh, there's some red buildings there. Importantly, datamux is not red. It has almost no complexity. But if we look at the red buildings, and if we really dive deep into that, we can ask ourselves, okay, why is this load initial file, why is it so complex? What makes it about file loading that is so complex? Maybe I can break out something there and say like, oh, okay, I can simplify in some case. What about the node decorator? That's just strange. Node was in the tag cloud. What's the decorator? Why is it so complex? And you have this view cube that doesn't even show up in the code in the word cloud. Why is it so complex? What does it do? And you have all these indicators where to start refactoring. And if you want to do that, you go for the active pattern and you go for the complexity limit. I mean, different teams decide on different complexity limits. You go for something like 20 per file. And one thing, easy thing you can do is you can remove indentation with guard clauses, meaning you have less in the if statement, and you try to guard against the bad stuff first, and then afterwards you have the linear stuff, the normal, the happy path. You can, of course, change a switch statement to something like a polymorphic dispatch. So instead of doing the case A, you just know this object, it implements an interface, and I just call the doThing method on it. And whatever I pass into that one, it's just going to do the same thing, but it's a bit easier to read and creates less complexity. Flag arguments. If you have a method that does something different depending on what you pass into it, how about giving each of these different things the most specific name? It will make the code easier to understand, because if you have a method that's called doThingTrue and doThingFalse, what does the true and the false actually do? I don't know. But if I give it a name, doThing or doSearch and doFilter, that's sort of, well, doFilter is a bad name, but you get the meaning, right? You can, of course, separate presentation from domain from data. These should feel very familiar to you. No rocket science, this is probably your day job, right? But now you know where to start. And you can group things that only interact with each other. And now you're at the point where, again, you can have new domain concepts to name. Next pattern, knowledge silos. If you have something in your code that only has one author, and that author has left, and it's complex and it's untested, right? You have a problem. And the knowledge silos pattern finds these problems. For code kata, it's a bit boring because we only have that one. And the reason why it only has one author is because it's, I don't know, 3 weeks old. So only one person has built it and the next one hasn't looked at it. Or, because of the way Git is structured, you cannot necessarily put 2 authors for one Git commit, even though it was pair programmed. So it's not perfect here. But it's good. It doesn't mean in this case we don't have to do something. But if we had a problem, we could go for the knowledge sharing pattern, which is less about doing something in your editor and more about communication. So what is right for your team will vary very much. And if you really want to share everything is also doubtful, because it's going to create waste. If I tell you about this really not complex thing today, in 4 weeks you're probably going to forget about it, right? So it's a bit waste to share everything. But if it's very, very important algorithm, you should share it. Because of the way our brains work, the simple code approach is the best one, because then you don't necessarily need to share it when it's so easy to read that everyone will get it. If it's not easy to write, maybe having a test as a specification will help a lot. You can also have something like, I'm the author of this thing. I only know about it. How about you over there, or you over there now write the thing? So, and then you can ask me about it, and I won't touch it at all. That is like more of a shadowing thing. Of course, pair mod programming, you've heard about it, and walkthroughs in your dev talk, techies meeting, whatever you want to call it. The opposite of the knowledge silo is the coordination bottleneck. That's when a file has 20 authors, meaning everyone has to touch it. Meaning I work on something, and before I merge it back, I now have to ask everyone, hey, are you working on this thing? The classical merge hell will happen. We have it a bit. Datamux. I mean, it has the generic name already, right? It's Datamux. I think it's not so bad here because the file is so huge that it probably won't happen that you work on the same part. But it's still something you want to look into and fix. You know, that's the thing when you create slides just before a presentation, you don't really have time to clean up all the things. But at the same time, now I have stuff to show you, right? And we have this nice thing called code map mouse event. Why does the mouse event have 20 authors? What does this mouse event do? I don't know, let's talk about it. Getting maybe into familiar territory, we have the next pattern, which is the multi-level dependency graph. If you take all the import statement from different files and you just graph it out, which file depends on which, well, you get a graph. Why multi-level? Because if you try to look at all the dependencies at the same time, you will go crazy. You sort of have to abstract. You have to look at it from different levels, from the most rough level, from the top, and then you can zoom into different parts where you're like, okay, why does this thing depend on that thing? Why is it important for domain? Well, if it's coupled in your code, the domain is probably also coupled. And that specifically creates problem when now there's also tangles, meaning it goes around and around and around in circles. Then you change the thing up here, and then you have to change that, you have to change that, and because you didn't change that, you have to change the original one. And to understand it, maybe even also have to go in circles. How does it look like? For CodeCarta, it looks like this. Created with, let's see, what did I write? Dependency cruiser. And I just pick one example, but maybe you can see it. That model as an upgoing dependency to util, and from util it also goes down. So you have that. It goes directly down, but it also does another circular thing. It goes to state, it goes again to model. So you have this tangle, and you really, really, really want to avoid that. If one of the earlier, dirtier patterns showed you, for some reason, that model, state, and util no one actually uses, you don't need to clean it up. But if one of these tangles is a thing that people actually use, and you want to put new features into it, yeah, this is going to slow you down a lot, and very unpredictably. You have, besides import statements, you also have the so-called temporal coupling. This one is tricky. I think it's by Adam Thornhill from his Code as a Crime Scene book. If a change in A often requires a change in B, the elements are temporally coupled. Right? So I make a commit to a file A, and in the same commit, I also change file B. If that happens enough, there's some form of temporal coupling. And this coupling is not necessarily visible. The import statements before, they also are visible. You can graph them, they're static. The reason for this coupling, which we'll get into, is a thing called coherence. And it's going to be very important for you when you want to clean that up. So yeah, you just count how often A was committed together with B. If it's high enough, you draw an arrow from A to B. And that's directional, because if the other thing doesn't happen, B was committed and A wasn't in the same commit, and if that happens enough, B is not necessarily temporally coupled to A again. It can be just in one direction. And if you look at this in the code map, you see that our lovely mouse event is temporally coupled, that a lot of stuff, because these are ingoing, are coupled to our mouse event. but there's no compile time, no import statement, nothing in the code that you could see. So how does that happen? How can it be that A can temporarily couple to B, but there's no static somehow relation? Right, you have these brown things, static couplings, import statements, and A to B, which is temporal. Both of these are a form of connaissance. Has anyone heard of connaissance? Can you raise your arm? Do I pronounce it correctly?
Yeah. Sure.
If the British guy says yes, okay. Okay, cool. Yeah, there was a.
You spelled it correctly though.
Oh, damn it!
You're missing an I.
And missing an I.
I think so.
Okay. No one knows. No one knows. There was a talk about it, or a lab, like 4 years ago by I think Paul Rayner here at DDD Europe. So the idea is this: two elements are connaissant if there's at least one possible change to A that requires a change to B in order to maintain overall correctness. If I if I change something in A, I have to change B, at least in one case. And there are now 9 strength levels of that. At the top ones are the ones that are very easy for your brain to understand, something like name. Yeah? If I have a variable, it's called, I don't know, author, and I use this author variable in some other place, that's a connaissance of name. It's very simple. It can also be the name of a SQL table, so it doesn't really have to show up as static imports. If I have a domain object author and I have a SQL table author, they have to usually have the same name. It's a connaissance of name. Type. If I expect an int, I always want an int. There are programming languages where you can kind of skew this and just pass in a string and it will sort of coalesce it to an integer, but well, for the most part, you want the type to match. And meaning. The flag we talked about earlier. If I pass in true in one place, and now the true means something inside the method, and the meaning has to stay the same between those both places. If I flip the flag, it have to flip it where I use it and where I pass it into the method. The null, enums, all of these are meaning. It's like if at some point I assign a meaning and I use it another point, those two things have to stay the same. And those are conceptual things, meaning they won't show up. They are temporal. You cannot see them except through temporal coupling. And there's 6 more. Yeah, if I did a talk on connaissance, we wouldn't, I think I need 2 hours. The thing is, sort of the top 2 are good, and the rest are kind of bad. Not like bad, you should never have them, but there are certain rules when it's allowed to have them, when it's not allowed to have them. We'll see them in a second. And the interesting part is the top 2 you can see, usually in your code. And the bottom ones, they are temporal. And they're usually the thing you also call duplication. Because if I duplicate the meaning in one place, right, there's also connaissance. It's really, I like connaissance because to me it explains many of these things we're supposed to avoid. Don't repeat yourself. And now it explains better to me why. Usually the bottom ones are very expensive to change and the top ones are very cheap to change. Why cheap to change? Because you just do Shift F6 and you just refactor, right? It's when the type changes or you want to rename, when the name changes, you do Shift F6. It's easy. Right. Of course, the top ones are more explicit and the bottom ones are very hidden. And you should definitely refactor this way. Now that you've gotten the 3 minutes connaissance introduction, this will help you fix temporal coupling. Because if you have connaissance of meaning on the left side, you switch on the movie code and you have the string case regular, at some point you have to assign this case regular. And where you assign regular, the string, and where you do the switch case, your interpretation has to be the same. Again, connaissance. And connaissance says, if you have meaning or execution order or whatever the higher ones are, you should usually refactor to a lower strength level. In this case, it's name. And you can do that very easy. You can put movie and enum in there. Yeah? Why is that better? Well, if I don't write regular, but regular, and I skip the R for some reason, I have a typo, this code is never ever going to execute again. But the enum is going to give me compile time execution, compile time error. So that's better. Later Java versions, I mean, I think C# doesn't have this yet. You have this stuff, sealed interfaces. Again, the polymorphic dispatch is also another possibility. You just, instead of doing the switch case, you just ask movie, hey, give me your amount. It's also better in terms of connaissance strength. And the lower one, this amount, this amount larger than 25. Why 25? Well, it turns out 25 has something to do, oh, sorry, skipped ahead one. 25, you could have something like an old people penalty. If you rent lots of stuff at the same time, you're probably an old person. I'm joking. Yeah, it's a appropriate solution is a team effort, big smiley, well, small smiley face. So, you've seen connaissance. If you're interested, I actually put a link in there because I don't have time to go into details. Now you can apply this. You can do temporal decoupling. You can find elements with temporal coupling, lots of them. You identify what type of connaissance you think it is, and then connaissance will tell you, hey, if you have very high strength level, try to go to the next one. Can you do it to the next one? No, okay, can you try the next, and it will sort of guide you along the way. You can, before that, however, you can try moving them closer together. Because if the connaissance is across your whole code base, you probably won't keep it in your head. But if it's, I don't know, one file over, it's much better for your brain. It's even if it's in the same modulus, even better. So that's another axis. It's not only about strength level, but also how close stuff is together. You can try to refactor connaissance to lower strength. And if everything fails, you don't know how to fix it, you sort of lock it. You say, okay, can we get away by not changing this code, like ever? Could be, right? You could decide I'm going to lock it. Of course, it's a business decision, but you can very, very strongly argue, hey, this is going to take you 2 years to fix. If you do this successfully, you again have new domain names to give. Next pattern, entity ownership. So, which part of the code owns an entity is highly related to which writes to the table. Is Mr. Ford in the audience? No, because he mentioned this in his keynote yesterday. So yeah, I subscribe to that theory. Why? Because the part of the code that writes the entity is the one that knows about the invariants, knows about what preconditions, what postconditions are allowed. So usually this gets out of hand. And the way to fix it is you sort of grab across your whole code base. You see these are SQL terms now. If you have no SQL, you have the equivalent probably in your own head. You grab all the select and you see which table is read. And you grab all the inserts, updates, and delete and see which table is written. And by that, you get sort of this graph. And you see, oh, this is just for one entity. But this one entity is written in 3 different components. And it's read also in 3 different components and in 4 different places. And the problem about these scattered writes, again, are the same invariants? Is the same contract preserved in all places? Can you be sure that it actually works? That all the code is the same thing? About the scattered reads, does everyone really need the same entity, or are perhaps the fields separate? And again, you now have a place to start. Not the solution, but you have a place to start. And you can go for the entity ownership bounds. You can be like, oh, don't write the entity if you don't own it. If you have to write, you can sort of delegate, call a method, hey, please, I want this to change. Other component, do this. It can do it by event, if you have an event stream in some form. If you have an event bus in some form. And if you do read, you can see, oh, can I split it? Maybe the fields are different that I need. And when you split it successfully, you probably have, again, new domain names to give. And here you can keep it in sync via events. Comparatively to previous active patterns, this is probably going to take you the longest time. And this is a lot of work. But now you have an idea where to start. Great. Along the road, you probably also want to capture what the domain intent is, because doing all these patterns, you have discovered you have gained a new understanding of your domain. And you want to capture that. And we're going to capture it probably with tests, but there's another thing we also do. And yeah, we'll get to that. Important part is these tests are different than the ones you're used to. You're used, at least likely, to these oracle-based tests. You're the oracle. You say, hey, if I pass these two values in there, I know what the expected is. Right? That's an oracle. And usually, you're trying to capture some form of behavior intended. But if you don't know what the intended behavior is and you just capture observed behavior, you do characterization testing, you don't really know what the domain reason is. That's a problem, because if you want to change this and you don't know what the reason is for this behavior, am I allowed to change this? I don't know. But at least you have something that ensures the observed behavior won't change. So it's a good place to start with characterization testing, but the more understanding you have, you want to go from legacy focus testing more towards the classic or the domain focus testing. There's two other categories of testing I won't get into, which is property-based testing and metamorphic testing. But you can find it in the backup, I think I put them, or ask me. So, but still, you're just capturing a snapshot. What can you do? Well, you can do a thing called the inverse object mother. You start your application without anything in a database, and it will crash. And then you figure out why did it crash. It probably requested something you had to have in there. Then you put that in database, you start your application again, it will crash, boop, 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 boop. And you do this using, well, simple factory methods like this: create user, create author, create book. And you figure out what is the object mother or the object mothers. Kind of like the other way around. Normally you would do object mother if you need to write a test. Now you just do it to figure out what is my domain at all. And at some point, because we're here still in the main method, your application will start finally, and you have your first characterization test. And then you can click through the application more and more, and you can discover even more about your domain. What does it need? Why does it need that? And so on. You can capture this outside in via a thing called test DSL. Why do I propose this test DSL? Because you want to keep your test structure insensitive. What do I mean by that? When you have something and you write a test for it, you call a method of that thing. If you have 1,000 tests that do the same thing, you're going to be very hesitant to change the thing you're calling. And if you are very low level or intermediate or somewhere along the lines, you're going to be just psychologically hesitant to change it. So your structure kind of gets cemented. If you go outside in and you put something special in between the test DSL, you get this. You call this A. I want a book. I want a user. And please just save it into my database. And down here, this testy is the only thing that you actually call. All the setup, all the things you might want to change when you know something, you abstract away behind the DSL. And the great part about this one is when you do a legacy code, you probably have a lot of stuff in your database. So you probably start with an integration test. But now, thanks to the abstraction, at some point you can extract all the stuff from your database, your procedural calls or whatever, and you change this one line, comes the unit test. And you don't have to throw it away, you don't have to write it anew. You can just take all your integration tests that you needed the database and you just change this one line and suddenly it's a unit test. Of course, that requires you to write DSL code. And you might be hesitant, but it's a very useful thing to do. Still, you start with characterization test, and you always look for opportunities to document the domain annotation, domain understanding with Oracle tests. Okay, I'm going to skip the annotation whiskers. And I'm going to quickly say something about North Star. At some point, you know what you want to have, the architecture you want to have, but you're still in a bad state. Using tools, you can document what you want to have. No classes should depend on classes that reside in a package service. And you can say, I'm going to freeze all my violations, but when future violations come, this thing is going to throw an exception. And you can communicate all this to your stakeholders using a thing called quality views. And that is simple. You just say, I have these components, they are in a bad state, pricing, renting, invoicing, but hey, they've gotten better, and if you want to put a feature in here, don't. Wait for us to refactor it. It's just about communication. And you put a bit of intent in there. You transform for future features. You had like slight quality dip, and this one here is the thing you tell your product owner, that one is locked. Please don't put any features in there. If you specifically talk to your PO, he probably wants to know what capabilities are in what state. You can go one level deeper and zoom in and put also that in your quality views. And then feature planning becomes a bit easier because you know, okay, this capability is in that state. This one is a very qualitative thing. You can usually approximate it by a fist of 1 to 5. Okay. Why all the effort to rediscover? We can just start anew, actually. I mean, why even do all this talk? Why talk about it? Because I think the feature-based rewrites have a very, very hidden true cost. You do this, and you have all your features, which are on the y-axis, and this is the rewrite you have planned. Easy. But the red line is the old system that also gets improved. They also put more features in there, and that shifts when you're finished. And you have to catch up. Program faster. Like I'm trying to catch up. But you're still subpar. because you only have the same features. And then you realize, oh my God, I didn't grasp the scope correctly. I have undiscovered scope. So I have to write the missing features. And you're still subpar. Well, a bit of parity, yeah, because you have all features. But why would anyone use your new feature, your new system? It's got the same features as the old one. Why would I use that? And then finally, you have the enhancement. And now people are like, oh, now I want to use that. But that means you have like a 4-time higher true cost of feature-based rewrites. And that's why I think your domain rediscovery patterns are important. And you should invest in them, and you can help your legacy code. Thank you.